in this example over here, we'll be sketching the graph of y is equal to x squared minus 2x minus 8 and its inverse, both on a set of axes. Now we want to ask ourselves, is this inverse a function? Now first of all, if we were to just draw y is equal to this parabola over here and the inverse, I assume that parabolic functions aren't too much of a hassle now. So I'm just going to leave you with the parabola over here, the positive parabola. But to find out the shape of the inverse, this part may be tricky because you need to swap your x and y values. So let's proceed with that. So solving for the inverse, we're going to be having x here instead of y, and all the x's turned into y. So we have y squared minus 2y minus 8. Okay, so if you were to make y the subject here, the best approach here may be to complete the square, similar to how you derive a quadratic formula. So over here, now we need to take half the coefficient of our linear term here. So we have half of negative 2, that would be negative 1. And just skipping a few steps for completing the square. This is what we get when we factorize the first three terms. And we get to plus or minus, or plus and minus, the square of half of the coefficient here. So we have minus 1 minus 8. So we have y minus 1 all squared minus 9. The reason why we go here is because we can get y by itself here, and you can actually rearrange everything such that y is by itself. But there is a small trick that you have to watch out for. So let's move the 9 over first. X plus 9 equal to y minus 1 squared. Now the next step to getting y by itself, naturally we'll get rid of the square here. So when you square root both sides, I'm just going to take y minus 1 over here to the left side. Is that when you square root both sides, remember that if you have something like x squared equal to 4, that when you want to find solutions to this, you need to consider the positive and negative solutions. So this is a very similar case. Square root of x plus 9 is the square root of x plus 9, but it's plus or minus. You need to consider both cases. So after that, let's just add 1 to this. Okay. So it looks like that we have two square root functions. So one is where you have positive of the square root of x plus 9 plus 1, and the other one is negative of the square root. So they're both going to have an endpoint at negative 9, 1, dictated by the translation of 9 units to the left, and translation of 1 unit up. That's why the endpoint is over here. And the positive solution, or positive expression from this plus or minus expression here, dictates the upper half of this purple graph. When you have negative of the square root, you're going to be going downward over here. Okay, and you can see that while you can find the x and y intercepts using methods that we've been using a lot previously, so make x equal to 0 for the y-intercept, vice versa for the x-intercept, you can recognize that if there's an x-intercept in its inverse, then that means that refers to the y-intercept of the original function. So if you had a y-intercept 0, negative 8, in its inverse, the x-intercept must be at negative 8, 0. We'll just swap the numbers inside on it. Okay, but is this a function? Now, the next part of this topic we'll be talking about inverse functions, so this is quite important. You won't always end up with a function after finding the inverse of a function, because what's happening here is for a function to occur, you need to pass the vertical line test of 1. Over here, you can see that for nearly the entire region where x is defined, the inverse, the purple graph, which goes like that, hits the vertical more than once for the most part. So it's not a function. Okay, and it goes to show that if you have a many to one function, so it's many to one, that the swapping of correspondence still occurs over here. So this means that, oops, not too many. So if we were to swap the correspondence and still have a function, it means that we need our original not to be many to one, but it has to be one to one for the inverse to be a function as well. So let's have a look at our next part. So in the second part over here, we want to restrict the domain of x to some sort of value a to infinity, so that the inverse of y is equal to x squared minus 2x minus 8 is a function. Okay, so just remember this part. The domain has to be between a and infinity, but we need to find the value of a. Okay, so over here, so where does the original graph go to infinity? So where x goes to infinity? It's on the right half of the parabola. So we're going to take everything from the turning point and everything to the right. So it doesn't make sense to have a to infinity if you start from the left, because it does say that our domain has to end up at positive infinity. So we need to go from the turning point. The reason why it's turning point is because it gives you the maximum domain of your parabola and still make it one to one. If you include any region, let's say from over here where I'm just scribbling, you can see that in the horizontal line test that you'll end up with a many to one function, and that's not what we want. We want one to one. So this must mean that our domain must be restricted from the turning point to infinity. So take this x coordinate here. So x must have a domain of 1 to infinity. Okay, and if that's the case, remember that the domain of your original is the range of your inverse. So when we draw this out again, what's going to happen is I'm only going to draw the right side of the parabola this time. So the right half. So we have 4, 0 here. And endpoint at 0. 1, negative 9. And if we draw the inverse, the endpoint is just going to have the same coordinate but reversed ordinates. So we're going to end up at 1, 9. Sorry, negative 9, 1. And since the original graph had an x-intercept at 4, 0, its y-intercept should be at 0, 4 now. And it seems like we have a function in both cases. So we start off over here, our original graph, our blue graph, will only ever hit the vertical once, and the purple graph over here, no matter where you strike its defined region, you can see that it will only hit the vertical line once. So this is one way to make it the original a one-to-one function, in order for its inverse to be a function as well, because you do have to swap the correspondence, and if you swap one-to-one, it's still going to be one-to-one again, and that's the aim over here.